So who's familiar with Grindr? Grindr is the application. Maybe hands up if I could see. Okay, so fair bit amount. So let me start maybe introducing who we are before we take the deeper dive. And to do that, I'm actually going to fire up the app. It's going to be easier that way. So Grindr is a geospatial dating app, and we specialize with we essentially provide geospatial dating service on mobile devices for gay men. And we are the biggest network in the world for that capability. We have users in over 192 countries around the world. We process massive traffic, and that, as you can probably know, comes with a lot of engineering challenges. Today I'm going to talk about the geospatial engine that powers this particular view. So when you launch Grindr, you essentially see who's around you, right? So these are all the guys around me right now. And I see Curtis with his shirt off. He's allergic to them. You know, you can kind of spin through, and you can kind of see the distance 54 feet away, 55, 65, and so on. So today we'll focus on how do we do that, right? But before we do that, I want to talk about scale a little bit. Grindr is powered, these iOS and Android native applications are powered by RESTful APIs for their core functionality. We process daily around 900 million API calls. Out of those 900 million API calls in that 24-hour period, we have around 200 to 300,000 geospatial calls. So those are anything that deals with updating on location or querying for location. So obviously scale is an issue. And today we'll try to answer some questions related why we're using Mongo for this purpose and what the journey was. So let me switch over to my presentation. And we are very lucky today because our partner MongoDB agreed to participate in this shindig, and we actually have Jake, who is a Mongo solutions architect. He's right there. And Jake is going to focus on some of the finer details of geosharding, and I'll talk about why would we even want to do that and what geosharding is. I'm Lukas. I am head of engineering in Grindr. I've been here for a year. And my job is to essentially build a very innovative, forward-looking engineering department, and also provide engineering backbone to Grindr service so we can scale and we can grow as a network, right? So, you know, I'm beginning to have a lot of gray hair because of the size and all the different issues that we have with being able to scale across the globe, right? Okay, so let's get started. So today what we'll talk about is essentially why Grindr selected MongoDB to power our geospatial capability. There specifically, I'll also highlight some of the other technologies that we looked at, and I'll talk about, from the very high level, the process that we went through. And then I'll talk about how we ended up with the cluster configuration that we have today. And there were many, many different iterations. We worked with some of the managed Mongo partners for that purpose, and that failed. And then we ended up actually partnering up with MongoDB directly and configuring and scaling that cluster ourselves. And I'll talk about why, right? And then we'll also talk about geosharding scheme and how we are planning to scale the current deployment, right? So I tend to think about all these different pieces of infrastructure as phases, and some of you who work here know I'm very big on phases. I don't like tackling large problems all at once. I try to divide them into smaller chunks and kind of implement them incrementally. So let's talk about the problem that we want to solve. So obviously, you guys saw, as a Grindr user, I want to see who's around me. All these numbers that I've thrown out there, they kind of amount to around 2,000 geo queries per second and around 1,000 geo updates per second. And those are essentially, who's near me, and then updating my location, right? Now, one of the things that is very special about us is that if you've used our app, our cascade, what you saw was a cascade of people, essentially, that's what we call it. Our data is very temporal, right? So we essentially evict you from the cascade after a certain amount of time. So what you see is always fresh users who have been online for at least an hour, right? After an hour, your record expires and it gets evicted out. So that functionality at the volume is fairly also difficult to implement because imagine if you had a SQL database and you had some sort of a flag, updating that flag at volume and then having some sort of daemons running that keep track of time and how long someone has been somewhere or whatever. It can result in solutions that are not that scalable. So we had this legacy solution that was replaced with this, with Mongo. And before I talk about it, I want to talk about why we replaced it. So we are very big on building an engineering department that enables innovation. And when you want to enable innovation, you don't want to get bogged down in solving things that already have been solved for, right? So we don't want to reinvent the wheel. The legacy geospatial engine was essentially built from scratch. It was leveraging Java-based custom algorithm that was scaled up by the team here, and it had essentially multiple execution pipelines that were trying to gather data. Gather data from multiple different data sources, and essentially, it was a combination of RDS calls, Reddit calls, Memcache, S3, and I know it kind of sounds crazy, but the old algorithm was trying to mimic something that Google solved for a long time ago with their open source geospatial algorithm, and we're trying to calculate these geoboxes depending on population density, and we had these daemons running around every hour to recalculate this whole thing that was storing a file in S3 that then needed to be consumed by this farm of 80 servers, and so on and so on. And the problem with that, it was working, but it was running really, really hot. It was powered by an infrastructure of 80 instances. And on top of that, if I wanted to say, hey, I want to find out who's around me, and then maybe geofence it by country or city or whatever, that functionality was not supported because it was custom, right? So we very quickly found ourselves in a spot where, like, okay, I want to do basic features at scale, and in order for me to do that, I need to hire a team to essentially enhance this thing, and I'm reinventing the wheel and reinventing something that's already been solved for, right? There were some good reasons to do this back in the day. I'm not going to get into that. However, we found ourselves at the essentially beginning of this year in January looking at our infrastructure and said, okay, well, if I'm spending all this time maintaining custom stuff, then I'm not being competitive. I'm not building new features, right? So what we decided to do was to essentially pick a new solution. And at the time, what we ended up doing was essentially look at various different technologies, and we said, okay, so let's look at these four things: PostGIS, which is essentially the extension to Postgres, Cassandra, DynamoDB, and MongoDB. And what we ended up doing is we started with the test harness first. So we said, okay, we know what our traffic is like. and we said, let's try to set up an environment where I can actually split my production traffic and essentially send my HTTP requests, RESTful API calls to this new environment, and set up this harness where I can experiment with different technologies, right? And at the time, we also started looking at, okay, so now I have this harness set up to test these things. What are some other criteria that I should consider, right? Some of them were, what is the cost to maintain the infrastructure, right? What is my DevOps footprint necessary to maintain my infrastructure, right? What is the support in the community? Can I partner with someone who essentially can own this functionality and help us, right? I am very big about forming strategic relationships with our partners to essentially extend our engineering team and enable it so we don't have to do all the heavy lifting, right? As much as I want to, I don't want to have a full-time DBA on staff just for MongoDB, right? We're too small of a shop. Our footprint is, right now we have probably around 25 people in engineering, and that includes, DevOps, NOC, applications engineering for backend, all the front-end development, QA and automation, all that. So all the functions is only 25 people, right? We are not big enough to be able to hire a DBA like that. And the reality is, if you're planning to hire one, then you probably need to have two of those people just to have redundancy and backup and all that stuff, right? So when you're thinking startup, the first thing that comes to my mind is what are some of the functions that I can either partner up with a company for, some other company that is very good at that stuff, and essentially free up my engineering department from doing these things. So as we're playing with these different solutions, we very quickly found out that PostGIS is doable, but it's very difficult to scale, especially when it comes to eviction policies. When you talk about this functionality of, you have relational database and you have essentially these tables with millions and millions of rows that get updated, and now you need to have these daemons running in the background to kind of look for people who need to be evicted, to either delete the record or mark them somehow through a flag. You very quickly realize that's just not going to scale. You run into major problems. So we abandoned that idea. Then we look at Cassandra, and also with PostGIS, it's not like I can very easily find a vendor that's truly recognizable in that space and be like, hey guys, can I have 24/7 support? Can you help me out with architecture? It's not that easy. There are vendors out there, but it's not that easy. Then we also look at Cassandra, and Cassandra is extremely good database for both reads and writes, especially on the write category. They can serve massive amount of traffic. However, in order to configure the cluster and scale the cluster, you need to have that in-house knowledge, right? Again, maybe you can find companies that can do that for you, but it's not as established yet necessarily. It's not like I can, find some managed Cassandra vendor, managed Cassandra instances in the cloud somewhere that companies are managing, right? So when it comes to Cassandra, very good technology, extremely scalable. However, you need to have that in-house knowledge, and you need to be able to hire people for that, right? We also look at DynamoDB from Amazon. Also, very viable solution because it essentially is managed service by Amazon. It's great choice, but at the time we were not able to scale it to the level that we needed to, right? So we got the other way. So we were able to essentially say, hey, great, this is an Amazon service. I don't have to have such a heavy DevOps footprint, but when it comes to actually being able to scale it, we run into some problems. So then we also looked at MongoDB, and we very quickly discovered that MongoDB is very mature technology, or maturing technology, with a lot of companies that offer managed services for Mongo, right? So we evaluated a whole bunch of vendors at the time. A couple of them come to mind, like MongoHQ and ObjectRocket, and I think there were two other ones, I don't remember the names. And we kind of did the same thing. We kind of asked them, hey guys, in your cloud, set up these instances. Here are our read-writes parameters, and we're going to send traffic against those instances. And we discovered a couple of things. Number one, that out of all these companies, ObjectRocket was the most mature at the time, and they had the right infrastructure to get this done. And incidentally, they actually got bought out by Rackspace, so ObjectRocket is now part of Rackspace. We still use them for MongoDB instances that we use for other not so high volume purposes. However, at the time, they were not able to make their abstraction layer to work with such a huge traffic, right? So we kind of banged our head against the wall there, and then we said, okay, well, out of all these choices, MongoDB seems as the best solution technically. It has great support. Let us start working with MongoDB directly and pair up with them to have it figured out. And that's exactly what we did. And that's why they're here. They're going to talk about some more advanced concepts. But long story short, we ended up essentially developing our own MongoDB cluster, scaling it very heavily with MongoDB's help. And that's kind of where we are today. I'll talk further in the presentation about where we're going. So let's talk about what our geospatial engine looks like. I'm sure you're interested. So remember, we had 80 instances running this custom thing, right? So after it was all said and done, we went to something like this. So we have now 27 nodes in production. The total data set is around 37 gigabyte. This is kind of a makeup of what this cluster is composed of, and some of the things that we've done. So we have obviously SSDs. We're running Mongo version 2.6. We're very heavily leveraging the MMS, which is MongoDB monitoring service. So we're leveraging MongoDB Cloud solution to help us monitor and manage the cluster. And as far as what that looks like, let me show you very quickly so this is a high-level diagram what we ended up with. So it's essentially 4 size 5 numbers each, with routers and big servers, and then the traffic is kind of scaled through the HA proxy from the beginning. So again, this is kind of many iterations where we ended up that we're playing against. We're playing with a number of these. So we start with 3. We had some like 5 or 6. And then we started playing with how are we going to spread reads and writes the right way across all these different nodes. So one of the things that we did, we also worked with MongoDB to help us to evaluate the queries, tune the queries to be able to essentially achieve that performance. And let me show you some of the performance boosts. Oh, before I go forward, so one of the things that's important here when you talk about your scaling strategy, obviously how you set up your collections. I'm not going to go into that because that's fairly proprietary stuff. But when you set up your collections and you choose your shard key, you know, it's a fairly important decision to make, and you need to usually work with some sort of solutions architect from Mongo to help you make those decisions. In our case, we are now sharding on profile ID, which is essentially this numerical key hashed that identifies each profile, which then assures even distribution of data chunks across the different nodes. So as the queries are running, we're not running into any hotspots, right? The last thing you want to do is queries that result in any hotspots on any of those nodes, because that's how you end up with bottlenecks, right? We've actually run through various different configuration for a couple of weeks at a time with production load, and we were monitoring the different cluster configuration to find out the best configuration possible, right? So what you see right now is highly tuned for our particular use case, right? When you're doing that and you're trying to do scale it up, you need to remember that you know, running just load tests that you conceive just from scratch that don't match your usage patterns in production may give you a false sense of confidence that, oh, I've done load tests and I can do 10,000 TPS easy, blah, 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 blah. And then you go to production and you find out very quickly that maybe a mixture of read and writes is not what you were testing with. And then you find out with a cluster that's not going to scale, right? So I would say that replicating and mirroring production traffic is very, very important, right? Now, if you don't have an existing application in the wild already, then that may be hard, but you need to spend a lot of time thinking about what is the mixture of reader writes, what are some of the indexes that I need to have, what are some of the filtering criteria that I have, right? And MongoDB can help you with that. Now, one problem that we have today with this is that, okay, so where are we going next? And I'm going to try to set up Jake for his presentation. Is that so this is all great, but all my traffic right now ends up in one Amazon geolocation, right? So all the traffic from around the world comes to us through Route 53 and ends up through our API layer, and I have this cluster sitting on the east coast of the United States, right? Well, if I have users all over the world, ideally, I want to bring the data as close to them as possible, right? So what we are thinking about to do next year is also distribute our infrastructure. So let's say people coming from Asia end up in appropriate data center, Europe ends up in appropriate data center, US ends up in appropriate data center, so on. We'll probably end up with 4 or 5 different geographical locations serving data. So that's great, right? So I'm going to have all these, you know, essentially API front ends serving traffic through Route 53 directed to based on where the traffic is coming from. Maybe we're going to add some additional functionality in terms of, like, you know, I'm going to be aware how hot certain data center is, maybe start offloading traffic somewhere else. Long story short, well, that traffic is going to hit MongoDB geospatial engine at the end of the day, right? So I need to think about architecture and topology that will allow me to then say, hey, if you're coming from Asia, your queries should be run against shards located as close as possible to those front ends, right? So I will have to take this and essentially take these shards and start distributing them into different geographical data centers, right? So that's our next challenge. The way our shard key is set up today, it's not allowing me to do that, because my shard key essentially, each query sprays the operations across all different replicas, right? So if I were to move all these different ones to different geographical location, I'm still executing queries across the whole cluster, right? My problem is I need to say, hey, if you're coming from Asia, you should only be querying replica sets that are only within that data center most of the time. If I have some outliers that go somewhere else, that's fine, but that could be tuned, right? So that's something that Jake is going to talk about how to do that. Yes.
So is the reason for this because your shard key is based on the user ID and that is
Correct.
That's not key to geography in any way?
Right.
Okay. So I assume Jake will talk about how you plan to fix that.
Yes.
Great.
Yeah. Yes.
Are you using secondaries for read like in file?
I'm sorry?
Are you using secondaries for read?
Yes. Yes. So a lot of reads are essentially distributed through those.
So is it secondary preferred as your read?
Yes.
Could you talk a little bit more about that HA proxy? Is that your app service, or is that?
That's because our legacy infrastructure, essentially the way we have everything set up right now, HA proxies use as a load balancing technology.
Just for the routers?
Yes.
Okay.
Okay, so before we go on with Jake's presentation, I'm going to talk a little bit about some of the performance boosters that we found in our journey. So let me fire that up.
Hey, can you go back to the slide where you had the version data?
Which one? This one?
Yeah. So you're on 2.6.0. And you didn't talk about monitoring at all.
Okay, so monitoring we're doing through a couple of ways. So we have our Nagios monitors on all the instances, just normal host. But majority of the monitoring is done through MongoDB monitoring service. So that's what's monitoring the cluster. That's when we have majority of the alerts. That's what we watch for.
Okay.
Yeah. And it's actually great because it's kind of running in MongoDB Cloud, and they can help you out with that. Performance boosters. So we use C3 2x large instances for majority of this stuff. Each has 8 cores, 15 gigabytes RAM, and 2 drives backed by SSDs. We also ended up data store resides on a Stripe LBA mount. So we also played around with those different configurations. And then we spent a lot of time evaluating our query patterns, evaluating what indexes we need to have, how do we configure the cluster to essentially spread the reader and writes across the whole setup. And the last thing is something that I already talked about. You know, when you're setting this up and you're starting to push some serious volumes through your clusters, I would suggest that you either talk to MongoDB or you hire someone who has done this before at scale. Because there's just we found, I mean, this whole process for us took around 3 months to kind of select technology and then tune it to be able to go live to production. And that's because we were running through various different configurations. We were playing around with different stuff, tuning the queries, and then, you know, each run we would have to then direct our production traffic, collect all the metrics, and compare. Right?
How do you decide on the C3 2Xs? And because you know it's fairly consistent with your choice there. Was that kind of through, okay, this is what we have the money to pay for, or you tested it, then if you did test
it was both. It was not so much of the cost. It was because the cost of the previous cluster was 3x of this, right? So we knew that we're gonna reduce cost anyways, but it was more about what the recommendation was. So it was again, you know, part of our testing and playing around with different setups, and also recommendations that we were getting from the experts. Right? The question is, you know, if I were to set it up myself in Amazon, and here's my traffic, and here are my query patterns, how would you do it? Right? And then you have conversation.
Why did you choose 5 nodes per shard?
Because of our makeup of reads and writes. Right, so we experimented that with as well. So we, at some point we actually had more replica sets that were not as deep, but then the way the queries were being spread around, there's some latencies or whatever. So we ended up with this configuration where we actually have more nodes in the replica set. Yes, sir?
Did you play with schema itself?
Yes. So we started with one collection, and the way the queries are actually run and executed from our front ends, we actually ended up splitting the collection into 2 or 3 different ones, just for performance reason. Where I started with was, okay, so I have the geospatial data, I have profile data that I want to filter by, right? So for example, give me everyone who's around me, but I also want everyone who is under 25, for example, right? So for me, it was like, well, I just want one query. Why can't I just have one query? And it was good in theory, but in practice, it showed that we actually had efficiency gains when we split that data into multiple different collections. And what I ended up doing is that we actually have 2 or 3 different execution pipelines in the code. And even though I'm running 3 different queries in parallel and I'm kind of assembling the results, that's actually faster than having just one query. Yes?
Are you using TTL indexes for data?
Yes, yes. So let me talk about that. So one very good thing that also we're using Mongo for is exactly that. So when you know, this whole scheme of, hey, you only exist in a cascade for 1 hour, right? So the way we solve that problem, we essentially, every time there's a location update, that essentially indicates that hey, you're alive, you're looking at stuff. We set a TTL on that record to an hour, and then Mongo just takes care of that. So I don't have to worry about deleting those records. They're just being purged through a normal mechanism to do that type of stuff. And then once that happens, you disappear from the cascade, and everyone is happy. Any other questions? Yes.
Are you using the query straight as a query, or do you do on-the-fly applications?
We do straight queries. Any other questions before I hand off the mic to the expert? Okay. All right, guys. So again, bottom line is, so this is this is a phase for Grindr, right? We were able to sunset a lot of custom stuff. We are running cheaper. We have actually faster results. But now we have an appliance that we partner up with Mongo to maintain for. We have enterprise support with them. Because it's a standard algorithm supported by them with a lot of geospatial query capability, now I can actually build on top of that and deliver a whole bunch of stuff like geofencing and whatever I want, right? Analytics. Okay.
Which Apple TV display was? Honeycomb. I've got a lot. Sit around. Alrighty. Can you email me the presentation? Or do you have it on a stick? I have it on a stick. Okay, I'll just grab your stick and present it. You already set up on that, so let's see. Ready? Yep. Yeah, just ignore that. Are you back? So only geospatial data necessary to power like geo queries lives in Mongo.
And so you still have some kind of fundamental push all that data into MongoDB.
Yeah. So we either these APIs that deal with that data essentially write to Mongo, and there are some APIs that may write to like RDS or Mongo.
Okay, can everybody hear me? No? Yes? Testing 1, 2, 3. Good? Good? All right. Well, good evening, everyone. I'm Jake Angerman. I'm a solution architect from MongoDB. Solution architects at MongoDB help customers in a pre-sale capacity understand the technology, design a scalable and reliable system, and eventually get them into production. So today I'm going to talk about multi-data center deployments, talking about some of the low-level details that Lukas alluded to. So I'm going to start off with a quick refresher on replica sets and sharding. How many people here are very new to MongoDB? Okay, so that'll be a good refresher. Some of you that'll be rudimentary, but it's a quick intro to get everybody level set. I'll talk about tag-aware sharding and how we can use it to scale out a scaled out deployment. I'll talk about shard key selection and why it's important. And then if we have time at the end, I'll do a demo of the MongoDB management service and give you a quick overview of what's new in version 2.8 that's coming out very soon now. Okay, so a quick review of a replica set in MongoDB. So if you have an application, that application is talking to a driver. That driver is supported by MongoDB. We have drivers for, I think, 15 different languages. So just about any language you could program in, we have a driver for it. And that driver is responsible for marshaling the data and sending it to a MongoDB database. And that database resides on what's called a replica set. And a replica set consists of a primary node and some number of secondary nodes that are asynchronously replicating write operations as they come into the primary. So if the primary were to go down for some reason, or there was a network partition or something happened, the remaining secondaries would hold what's called an election and elect a new primary to take over. Yes?
So that's like a failover configuration, it's not active-active?
So active-active comes from your data center deployment, and I have a slide to discuss that coming up, but this is just basically it's high availability, it's not scalability, right? So the way it works in MongoDB is you have an odd number of nodes, and so you'll usually see MongoDB deployments with 3, 5, 7, 9, etc. And the reason why that is because you need a majority to elect in an election a new primary. Okay, so as long as there's a majority that's active, you can elect a new primary and life will go on. Now, it is true that if the primary goes down, the period of time to elect a new primary is on the order of magnitude of seconds, like 3 to 5 seconds. It's not on the millisecond level. We're working to improve that in future versions of the product. But as an application developer, you need to plan for and test and write your code so that if you have problems doing a write operation during the election process, you need to handle that exception and retry or queue it up or whatever you need to do. Okay, so that's how you achieve high availability with MongoDB, by having what's called a replica set. So any questions about that?
Yeah. Is there any, how do they choose, random or the election? How do they?
Yes, so it's configurable. So the question is, how do you determine who's primary and who's secondary? So you have the option of configuring it such that it doesn't matter. So if you have the philosophy of, applications, your servers are livestock. If one of them gets sick, you shoot it in the head and get another one. You can say, I don't care which one becomes primary. Some customers like to have, say, an affinity for a certain node to be primary. You can basically set a priority so that when there is an election, if that node is available, it will win the election. So it's configurable by you how you want to do it. So some people care, some people don't.
During the election process, is there a special message that it will respond, saying election process will take place with generic?
So what will happen as an application developer, you will get an exception when you try to write. And if you look in the replica set configuration, you will see one of the, election is underway. Like you'll see in the status of your replica set that election is underway.
So how would the application know if an election is happening? If, like, from the program, just hold like 3 seconds if you see this message.
Yeah, so you would get an exception, right. And I don't know what the exception, how it would be formatted in whatever language you're thinking
but
of.
It would be different than like some other. Is it election specific?
No, it would just be a write exception. So you wouldn't know whether it's an election is taking place, or maybe you can specify a write preference. So like if you really care about durability, you can say don't acknowledge that write until all 3 nodes get it. So you would just get a generic exception. Okay. Any other questions before we move on? Okay, so that's a replica set. So my data is basically my writes are going to the primary. I can read from secondaries if I choose to, but by default everything is going to the primary. So how do you scale out a MongoDB deployment? So the way you do that is with sharding. So when you shard a MongoDB deployment, you are basically creating a series of replica sets, and those replica sets contain partitions of your data. So in this particular example, I've got n shards. I've subdivided my data such that the driver is now talking to this intermediate layer right here called a query router, and that query router has knowledge of which data resides on which partition. So as an application developer, you never know that you're running a sharded configuration. The application has no knowledge of that. That's completely transparent to it. So you continue to write this, the same code that worked yesterday will work today, but now you're sharding, and that's all done under the covers, and it's basically decoupled from you. This query router, I've drawn it here as a separate physical layer. It's actually a logical layer. You can put that query router process on the same node as your application server, and that's how most people do it. So basically, you have this intermediate layer that's knowledgeable about what data is where. It's able to take a query and route it to the appropriate shard. Okay, any questions on that? Okay. Okay, so let's talk about some deployment options. So here I have a single data center. I have a sharded cluster consisting of 3 shards. They each have a different color. So I've got A, B, and C. In this particular configuration, I can tolerate the failure of an individual node, and I can tolerate the failure of an entire rack. So if an individual node fails, then I have 2 remaining. Since 2 is a majority of 3, I'm good. I can have an election and elect a new primary. If I lose an entire rack, I'm still okay because I still have that majority for the remaining nodes. So it's not fault tolerant to the level of a data center. If the entire data center goes out, you have a problem. But at least from the individual server or rack, you have automated failover. That's baked into MongoDB. There's no special option you have to do there. That's baked in and part of the product. All right, so that's a single data center. What happens if you have 2 data centers? So in 2 data centers, you could have, say, a West Coast and an East Coast data center. This will also tolerate an individual server and rack failure. And it will also, if you have, like say the West data center goes down completely, you have a standby data center over on the East data center, but this is not automated. So because if the West data center went down, I would only have 1 out of 3 nodes in each replica set remaining, so I couldn't hold an election at that point. So this is a manual failover scenario. Some customers like manual failover. It's just part of their business process. They've been doing it for other databases forever. This is just normal operating procedure, and they're fine with that. So if the data center goes down, you can still recover, but you have to recover manually. Okay? And then, question? Okay, so, yeah?
A quick one.
Yeah?
So when you have more than 1 data center and they're geographically separate,
yes.
Do you usually recommend to your customers to consider a safe write to all the shards, even if they're separate? If that takes longer, or
it does, and so you can tune each individual write operation. So it's not like you have to say every single write has to have that durability. A good practice is for customers that really care about very specific write scenarios. Yes, they do have that restriction on that particular write operation to acknowledge, all 3 members of the replica set or a majority or something like that.
Is there one that people tend to favor?
It really depends on the application. So like if you're gathering a bunch of log data, who really cares, right? But if you're doing like a financial transaction or something like that, where it really matters, then you would want to do that. But it's usually done on a case-by-case basis. It's not a blanket statement for all of your rights. So here's the third configuration. I've got 3 data centers. I've got a West Coast, an East Coast, and now I have a Central. And the beauty about this scenario is I now have completely automated failover. So if I lose an individual server, a rack, or an entire data center, I now have completely automated failover because there is a majority remaining, a majority of nodes remaining in my cluster that I can survive that. So this is kind of like the Rolls-Royce deployment. If you want to have completely automated failover in 3 different data centers, this is how you would do it. Okay, so imagine for a moment that instead of data center, it's Amazon region. And instead of rack, it's an availability zone. It's the exact same concept. So that's what I'm going to be talking about today. I'm going to be talking about specifically AWS, talking about geo-sharding with different regions, and you can just take this analogy of data center and rack to Amazon region and availability zone. Okay, so here's a deployment that's very common in financial services. This is kind of a confusing diagram because there's lots of arrows going everywhere. Basically, you have a sharded cluster consisting of 3 shards. You've got the green shard, the brown shard, and the gray shard. So like I have a primary in New York City, and I have secondaries in London and Sydney. So the idea is for each geographic region, I have a primary that is local to that region. So I'm doing all my writes to that particular primary. And then the secondaries in the other geographic regions get read access locally as well. So that would allow a financial transaction to happen in London, but then somebody in Sydney could see that milliseconds later or however long it takes to replicate over there. So this is a very common deployment scenario for multiple geographic regions in financial services. Okay? That's not what I'm going to be talking about tonight. So what I'm going to be talking about tonight is the use case that we've described already. So the use case is I have my mobile phone, I walk into a business or Starbucks or whatever, I check in on my phone, and I want to see who's around me. So in that particular case, I'm going to want to write locally and read locally as well. So nobody in Singapore cares what I'm doing in New York City. So I'm going to have basically 3 geographic regions here. So Amazon has more, forgive me, I left out South America because I ran out of space here. No offense to South America. So I'm going to pretend for this thought experiment we're going to do that there's only 4 regions in Amazon. We've got US, Europe, Asia Pacific, and South America. Okay, so any questions about this before we move on? Okay, so let's talk about tag-aware sharding. What is tag-aware sharding? Tag-aware sharding is assigning a tag to a range of your data based on your shard key to reside on a specific shard or group of shards. So this is very useful in the geographic case that we're going to talk about tonight. It's pretty straightforward to understand. It's also useful in the hardware scenario. Like a lot of our customers will have their data, the data that's most recent on SSDs. So they'll tag their servers that have SSDs with a certain tag. So all of their hot data goes there. And then they have like a tag on their servers that have spinning disks such that after a certain amount of time, like after 6 months or a year, that data will get migrated from SSDs off to slow spinning disk. And they don't really care that that's slow because it's archival data. So you can use it for geographical usage or from a hardware archival perspective as well. Those are the 2 common use cases that we see. Okay, so like I said, let's pretend I'm checking in with my mobile app. I'm going to do a geo query for others around me. And let's pretend Amazon has more than 4. There's like East 1, East 2, West 1, West 2, and all the stuff in Europe. So let's just pretend for the sake of this experiment that we're just going to have 4 regions in the world. Okay, so let's add some shard tags to my shards. So I created a cluster with 3 shards, creatively named shard 0, 1, and 2. And I assigned a tag to each corresponding shard to contain just that data. Okay, So right now, after I do these commands, nothing's really changing in MongoDB. It's just applying a tag. It's just a tag is just like a tag in any other system. Like, it doesn't have any inherent meaning. It's just you're just assigning it a tag. You're not actually doing anything with it yet. So when I do a shard status command, I can see now that my shard 0 has a tag of US, and correspondingly the other two shards have tags assigned for their region. Okay. Any questions? Yes.
So is this done dynamically, or is this something that I am actually doing on the back end, like one time, based on some criteria that I developed?
It's done by you, and you can do it whenever you want to. There's no outage you have to take or anything like that. Did I answer that question? I'm not sure I got the gist of that question.
No. Okay. So for the particular scenario that Grindr is trying to figure out, you know, they obviously want people that are in, say, North America,
right,
and South America to be in, you know, to hit a server in the U.S. Right?
Yep.
So I assume that they will determine the geographic location of their users based on like IP address or something like that.
Yes. So I've left that out of this presentation. Each application server is going to have an innate knowledge of what region it's in. That could be a configuration file. If we have any DNS experts in here, they can explain how DNS tricks you can use. It used to be global server load balancing. Whatever technique it is, let's just pretend that the application server knows what region it's in. So that gives it the ability to do queries and writes with some key or some value that's unique to that region. Okay?
Sure. Well, so my application server is going to know what region it's in.
Right.
I assume that the application server, I can write some stuff that I will know where a user is. But you know, the key with this is each time a user logs in,
right,
is it practical to tag them with a location, or is this something you would only want to do once?
No, you would want it dynamically.
You would want it.
You would want it dynamically, and I'll give you an example of why that's true in a subsequent slide.
Okay. So
like if I check in New York City, I get on a plane, I fly to London. I would have 2 check-ins, but they would be in 2 different shards, and that's totally okay. Okay.
Yeah, that's what I was getting at.
Yeah.
It's like what happens when somebody gets on a plane.
This will become apparent in subsequent slides.
Okay.
So at this point, I've just added a tag. That's all I've done. I haven't set up any rules or any intelligence about what those tags mean. I've just assigned a tag. Okay, and so now I'm going to assign the ranges. So I'm going to say that I didn't do this in alphabetical order, but it doesn't really matter. So I'm going to say that I'm going to add a shard tag range. I called my collection check-in, so I'm only thinking about checking in. So it's called check-ins. I'm saying that everything between and including Asia Pacific but excluding EU, I'm going to call AP. Everything including EU but excluding South America, I'm going to call EU. It's always inclusive in the lower bound and exclusive in the upper bound. So maybe this will become more apparent. But basically, I'm setting up a rule that says when I'm doing an operation, I've set up what data goes where based upon a field in my document. Okay. So this is where I'm applying the logic of what goes where, and this will become more apparent as I move on. Okay. All right, so let's talk about shard key selection. So a good shard key has 3 characteristics. It has sufficient cardinality. That means there's enough of them. MongoDB will auto-balance the data on your shards, and it does that by assigning ranges to certain chunks, and it can move chunks around. So if you have one replica set, and you turn that into shard 0, then you add another shard, MongoDB will automatically move data off of that first shard so that both shards have the same amount of data. And it can do that if your shard key has sufficient cardinality. So like, I'll give you an example, like if you just had 4 values, that would be bad because I could never have more than 4 shards. I can't subdivide that anymore. So you want your shard key to have sufficient cardinality. The second characteristic you want is distributed writes. So Lukas mentioned this previously. You do not want to pick on one shard when you're inserting data. You want your writes to be distributed amongst your entire cluster to get parallelism, which is more efficient. And then the third thing you want is targeted reads. So when I do a read, I don't want to go query every single shard. I want to have my query go to a very focused shard, hopefully one, possibly more than one, to get the answer that I need. That way it's more efficient. Okay, so the shard key should be in every query if possible. It's not always possible to do that, but you should strive to do that. And the reason why is if you don't do that, then your query is going to become a scatter-gather query, and you're basically going to send the query to every single shard, and you're going to have to wait for every shard to return, and you're basically going to be waiting for the slowest shard to get back to you. So you want to include that shard key in every query if possible. So like Lukas said, choosing a shard key is very important. It affects performance and scalability tremendously, and it's very hard to change. So choose wisely. And I'll show you how to do that.
So when you say it's very expensive to change, how expensive is that?
Let's lift and load your data from this collection over here.
So for instance, like you have 4 shards, right? But
Yep.
I want to redistribute it into 5. And that is going to be difficult to redistribute the probability of order sets.
No, because when you're adding a new shard and you're not changing your shard key, that's just a copying operation. So it'll take 1/4 of the data from each thing and move it to the new 5th shard.
Well, I understand.
Yeah.
We add another shard in that for another region that is kind of like a subset of each of these the other shards regions.
I mean overlapping ranges?
Or extract some of the what's it like Asia Pacific. You want to break it into Asia and then Australia.
Yes. You could, yes. So if you decide to, so that's still a copy operation. You're not changing your shard key.
Okay.
You would be adding a new shard. It would have a new tag, and the application servers in that region would have a new region called, SID or Australia or whatever. Okay. So what you just described is not bad news. It's bad news when you decide I want to change my shard key completely. That's because you basically have to copy all of your data again. So that's very expensive. So it's important to choose a good shard key. Okay, so there's basically 2 different types of shard keys. There's range-based shard keys and hash-based shard keys. So range-based is pretty easy to understand. If this is my set of data, I take different subsets of that data, I chop it up, and I distribute it. Very easy to understand. Hash-based sharding, basically you hash a field in your document, and that allows for random distributions on writes. So it's really, really good at data ingestion because you are spreading your writes out by definition to all of your different shards. Okay. So let's talk about the hash. Yes. Yep.
Hash will kind of repeat your targeted query.
Yeah. You can't do range-based queries with a hash shard key. How could you? Because MongoDB would have to hash every single, it couldn't possibly do that. So it's really great if you want to take a piece of data that's not in a range and you just want to store it someplace really fast. But if you want to, do a range-based query, you basically can't do that unless you do a scatter-gather with a hash shard key. So no. Everyone is asking questions about stuff I have on subsequent slides. So I think that's true for every single question. So the pros of a hash shard key is it evenly distributes writes. That's good. The cons are if you update data, it can be very I/O intensive because if I am writing data, if I'm ingesting it at a high rate and then I want to do an update, I'm going to have to go to disk potentially and get that old data that I'm updating and bring it back into RAM. That's very expensive. So that is a potential downer. And like I said before, range-based queries turn into scatter-gather. So you basically can't do range-based queries. But there's another reason why we can't use hash shard keys in our scenario. So hash-based sharding does not support tag-aware sharding. So that is a reason why we can't use it in this particular use case. Now there's a bunch of other provisos here that I'm not going to read to you because it'll make your head spin. Basically, the only thing you need to remember from this slide is this very first bullet. You can't use hash-based sharding with tag-aware sharding. So that disqualifies hash-based sharding for our use case. We can't do it.
So is it possible to do something where you combine the two by splitting based on range into some kind of cluster and then you shard each cluster by half?
Okay, range-based shard keys. So an example of what not to do is create a low cardinality shard key. Because what that'll do is it'll induce what's called a jumbo chunk, where you have a chunk of data that MongoDB can't subdivide anymore. And it just grows and grows and grows, and there's nothing you can do about it. So, for example, if I chose an AWS region as my shard key, I would start off with shard number 1. I would have Asia Pacific as my lower bound and positive infinity on my upper bound. That would contain all my data. And then I would decide, okay, I've got too much data on that shard. I need more shards. So this is just a fancy mathematical way of saying shard 1 only has AP, shard 2 only has EU, etc. And after that, I could never add any more shards because I can't subdivide EU anymore. There's no way I could do that. So I would just keep adding. The only thing I could do would be add more disk space. That's all I could do because you can't subdivide AP, EU, or SA anymore. So how do you get around this problem? You do it by using a compound shard key. So an example that's very popular is an arbitrary value and an incrementing value. That's good for range-based queries. That's not what we're doing here, but the idea here is I've got something that has coarse granularity as the first element of my compound index, and something with fine granularity as the second part. So what that does is it allows me the best of both worlds. I get distributed writes because I can put all of the data for EU on a given shard, but because I have this fine granularity shard key as the second part, MongoDB can subdivide that and move that around. So if I decided like my European traffic took off and I need to add another shard, I could tag it with EU, and MongoDB would be able to split that data and migrate the data that's on the current EU-only shard to 2 EU shards. So this gives you the ability to have more than 4 shards in this particular example. Yeah.
How does Mongo decide between like if you use this kind of username, you never really know how many of them and how they branch. What percent of the logs?
It does it by looking at the amount of data that's being written to each shard. So it'll detect an imbalance in terms of this has more than the other, and exactly which chunk of data it chooses, I'm not really sure what the algorithm is.
You mean like it will be kind of rebalancing as you change?
Yes. Yes.
All the usernames suddenly like start talking about, hey.
Yep. Yeah. That's all handled automatically for you. You don't need a DBA to go in there and do that for you. That's all handled by MongoDB. It's called the balancer. That's the process that goes in and balances everything. Okay. So any questions? Yes.
Sorry. Maybe I'm misunderstanding. So when you say this now Mongo can split this into more than 4 shards, does that mean it's going to consider in the thing that you said where there's the first key is EU and there's 2 second key and it sends it into 2? Is it 2 like servers of the same shard or 2? It's considered 2 separate shards.
So let's take this example. This example I have 4 shards, and
and they're sharded and they're split based on the first key.
Correct.
Right.
Correct. So let's say my traffic in the US takes off, and I want to add a new shard 5. I would tag it with US, and then MongoDB would detect an imbalance there, and it would migrate half of the data from here to the new shard. Okay. All right. Okay, so here is what it would look like for this mobile app that I've dreamt up. So let's say I have 2 shards here in the US, 2 in Europe, and only 1 in AP. Sorry, South America, I didn't have enough room. So here's where the magic happens. So I'm going to create an index. I have a field in my document. When I do a check-in, I have a field called location, which is a 2D geospatial index. And I'm going to run a command. So this is my query where I'm actually running a query on the check-ins collection. Show me everybody who's near this coordinate. And let's say I'm in Asia Pacific, I specify as part of my query Asia Pacific. So what's going to happen is MongoDB is going to say, okay, I'm going to do a query for everything that's in Asia Pacific. That means that I am going to redirect that geoquery only to my shards that have shard keys that begin with AP. So I'm still doing a scatter gather, but I'm only doing it on the Asia Pacific shards. So that limits my query only to the geographical region that I'm checking into. So this goes back to the question of, I'm in New York and I fly to London. So I check in New York. There's an entry in the check-ins collection for US, Jake. and I fly to London. I get off the plane. I check in. There's an entry for EU, Jake. Those are two totally different pieces of data in two different shards, and that's totally okay. And then that TTL index will notice while I'm still on the plane, because it takes more than 1 hour, that TTL index will say, oh, he hasn't refreshed in an hour, and I'll get deleted from over here, and I'll show up over there. You're not buying it.
No, the part that I'm trying to wrap my head around is that so there's actually like multiple pieces of data associated with, for example, this particular mobile application, right? So, yeah, there's like a picture, there's a user profile, there's all of that data.
Yep.
So, what part is resident in London? It's like, the fact that I'm logged in and the TTL, that part's sitting on the shard in London. Is all the rest of my data still sitting in the US?
Probably. You're probably going to have a separate collection for user profiles, and that's going to reside in your hometown or whatever, your home base of operations. I'm only talking about the check-ins right now, the check-ins collection, but that's going to be a totally different collection than your user profile data. So it's true that if I get off the plane in London and I want to update my profile, I'm going to have to write that to a server in New York, but that's okay because I'm not going to do that very often, and that latency is probably it's not going to be too bad because that's a totally different scenario that I'm checking in, and I don't want to see a spinner on my mobile app. I want that to be fast.
Oh yeah, totally. Yeah. So I guess the other question is so for that separate collection, I would assume that you do exactly the same thing as you're doing for check-ins, and it would be based on wherever the user initially creates their profile.
You could. That's an implementation decision that I haven't really considered this, but I mean, it's up to you. Like, is it really? Actually, I have a slide. Is it the next one? No, I have a slide, 2 slides from now that talks about usernames. So hold that thought.
Okay.
Another question?
Yeah. So you're not manually. You already sort of said you're not manually setting what like those upper and lower bounds of like the username are. So what actually, when you're typing in these settings, what are you actually typing in for like US aws-opsworks, US BOP, or what does that look like?
So all I did was I created a shard key that specified region, username. So MongoDB now knows that that is the shard key. So when I'm inserting a document, it will insert a document and write. It'll know to go to the US shard because that field name has US in it. Did that answer your question?
Yeah.
Okay. Okay, so here's the final configuration. So I've got my 3 shards here with their tags, and down here you can actually see the ranges. So I've got a min key, AP, my AP, minus infinity, all the way up to, but not including EU, minus infinity goes on shard 2, etc., etc. Now, to be mathematically correct, I should have created minus negative infinity EU as my AP shard, but that would have been hard to illustrate. So MongoDB actually inserted a 4th chunk range right here that will never get added to unless... So basically it goes from minus infinity in terms of the region all the way, but not including AP because I didn't specify it. But if Jeff Bezos ever created an Antarctic region, Antarctica would go in here. But that's never going to be used in this example.
The range is determined by essentially the alphabetical order of the...
Yes.
So
That's correct. Okay, so let's talk about usernames for a minute. So the scheme that I've just demonstrated, I had a slide here that showed, notice how this is Alice 4, Alice 2, and Alice. Those are different Alices. Default out-of-the-box MongoDB wouldn't enforce that because the way that I've specified it here, it's totally legal to have an Alice in the US, an Alice in EU, and an Alice in Asia Pacific, because those are 3 different Alices as far as MongoDB is concerned, because the shard key's different. So that could present, a problem. It might. So if your application, if your business, it's more of a business discussion than a technological one, but if your business wants to have globally unique usernames, you would need to do something to get around that. Now, if you can tolerate having identical usernames in different regions, that's fine. But the way people get around this problem is they'll create a separate collection that's not sharded, and they'll put a unique constraint on username. So when you create your account, if the insert works, you know it's unique and that username is not taken. So that's good. And if you get a failure, that means the user has to choose another username. So minor detail, I don't want to dwell on it too much, but if globally unique usernames are important to you, there's a technique to handle that situation in this particular use case. Yeah.
So on the Node.js driver, because I was doing this on points, like on the Node.js driver, you set, because you can do the feature where like it doesn't write unless it's unique. So you're saying you couldn't build it into the distributed geo layer, so that you could have that at like a driver level at the top level, so that if you would be aware of all the elements,
so
you'd have to separate. So
what I'm saying is, if there's an Alice in Japan and Alice in New York, those two Alices could create accounts and check in in the way I explained it.
Mm-hmm.
So is that okay or not okay?
It's not okay, but I was just saying, like, if you have a driver with the driver lets you set, like, must be unique to write this this value, right? So I'm just wondering if in the setup you have, could you use a driver to build in a must be unique at the top level?
Not on the sharded check-ins level.
Okay.
Because as far as MongoDB is concerned, AP Alice and EU Alice, they are different, and that's okay.
Oh, because it's a compound.
Yes,
right?
it's a compound. It's a compound index. So MongoDB thinks everything's fine. So if you want to assert that, then you have to do a little bit more work. But just a side note, really. Okay. Any other questions on that?
So this,
yeah.
So this unsharded collection would reside in just one place, just to serve as a check-in.
Yes.
Whenever you record any of the services?
Well, it wouldn't be a check-in. It would be on account creation. So when you create your account, yeah. And so I can see where you're going with that. Like, yes, there might be some delay because it's going to be centrally located and uncharted.
Right, but it's minor.
It's only going to happen once in the account's lifetime. It's not a big penalty to pay.
Yeah.
Okay. All right. Any other questions about any of that? Okay. So now I'm going to give you a quick demo of MMS automation, which Lukas alluded to. Okay, so I actually set up a cluster in the MongoDB management service. So this is MMS. This is the thing that I used to create this demo. And so you can see that I have 3 shards right now in my little cluster. So MMS gives you the ability to automate the deployment of this shard. It allows you to monitor it and allows you to back it up as well. So all of those 3 things can be done within this console. So I'm just going to give you a quick demo of automation. So one of the things you could do is you can go in, and if you use AWS, we have tight integration with AWS such that you could actually spin up AWS nodes within this interface and immediately create replica sets or sharded clusters out of them using those nodes. So you don't have to go visit an AWS console. You can just do it all within MMS. If you're not using MMS, that's fine. You have to install an automation agent on your node so it becomes discoverable by MongoDB. But so let me do a quick little demo here. I've got a sharded cluster here. It's running on version 2.6.4, and 2.6.4 is in red font, indicating that it's not the latest version. So I'm going to go into edit mode, and I'm going to upgrade this cluster. I'm deploying. Okay, so earlier today, somebody rebooted my cluster. I can't do that demo now because something is in progress. All right, well, anyway. So with MMS, I could say, I want you to upgrade this cluster from 2.6.4 to 2.6.5. And MMS, what it would do, it would go out to each individual shard, and it would update the secondaries to 2.6.5, and then it would ask the primary to step down, and then the remaining secondaries would elect a new primary, and then it would update the machine that was primary to 2.6.5. And it does that all automatically without having to click a lot of buttons or log into the command line and do 17 different steps from a manual. So that is great for doing upgrades. You can also scale out a sharded cluster. So like if I had a lot of success and I wanted to grow my cluster dynamically, I could spin up a new cluster in MMS without visiting an EC2 console and say, okay, spin up that cluster, and it would add it to that sharded cluster. I'd still have to go in and add the tags manually because you can't do that from the GUI, but at least the provisioning part would be done automatically. Okay. Any questions on MMS? Okay. So, am I over my time? Am I getting the hook? Okay, okay. So let's talk a little bit about what's new in MongoDB 2.8. 2.8 is coming out real soon now. The big news there is collection level and document level locking. In the current version, in 2.6, we have database level locking, and in 2.8, we demoed this earlier this summer, the prototype. You'll be able to choose between collection level and document level locking. So that's important for concurrency and for use cases where data ingestion is really important at a high rate. So that's going to be a huge performance boost for MongoDB for write operations and concurrency. Other things that are new, auditing CRUD. So today you can audit administrative actions like Joe Blow created this collection, Joe Blow logged in at this time, like administrative kind of stuff. In 2.8, you'll be able to audit like who's doing queries, who's doing writes, when did they do it, that kind of stuff. So that's coming. So administrators love that kind of stuff because it helps with environments where compliance is very important. In terms of geospatial, we are adding a feature to do a big polygon search, which is greater than one hemisphere. I have to admit I'm not an expert as to exactly what the implications are from an application standpoint. I did list the server ticket there, so if you go into our Jira system, it's open, anybody can read it. You can read up about it. You can actually go into the Git log as well and look at the code commit for that to see what it's doing. So big polygon search is coming. And we're also increasing the number of nodes in a replica set. It's currently limited to 12, and we're bumping that up to 50. So the number of votes is still 7. That doesn't change, but the number of nodes in the replica set will go up. That's useful mainly for like product catalog use cases. So basically, you're reading data all the time, and you just want to scale out. I mean, obviously, people update their product catalogs, but it's basically a 100% read kind of system. So that's useful in that particular use case. All right.
What about storage engine?
Yes. So that is part of the collection level and document level locking. The storage engine is an API, so we'll have a couple of storage engines available, some new storage engines. But the real news there is not so much the number of storage engines that we're going to have that are available, but basically we're making the API for storage engines available to anybody who wants to write their own. So it's not going to be this huge catalog of things that are available, but we're opening it up to partners or developers who want to write their own. So presumably after 2.8 comes out, there'll be a lot of development in that front, and people will be writing their own storage engines for whatever, like if they have a key value store or RAM-based or whatever storage engine. Maybe. I can't, yeah.
So really quick, we're doing a phase release of level storage engines. We've got stuff like that guarantee first. But there's also conversations about what are the other storage engines that make sense versus cost. We're actually making things like actually develop that data framework we have in storage. But those are all moving pieces. We want to make sure we get the content first, which is why we're focusing on document blocking and some of the core functionality when it comes to level APIs for storage. And then after that, we're going to have all of these other storage engines that will be coming out and saying, later release to base. So that's something that we don't have to commit in regards to documentation, but I've got muscle confirmation from a few different product managers who have product mock-up saying that's going to be coming out further.
So not so fast on the
well, we can't commit to in-memory yet, but I know it's definitely on the catalog prioritization, which ones we want to outline first.
Okay. Yep.
For concurrency's sake, when is collection level lock better than document level lock?
It's going to depend on what storage engine you want to use. So if you have a high rate of concurrency, document level locking under most circumstances is going to give you the best concurrency. but you may say, you know, I have a level of concurrency that's good enough, and collection level locking may be good enough, and the storage engine that supports that is something that I'm comfortable with supporting in production. So we're leaving the choice up to you, really. Yep.
Can you go over what you mean by collection level and document level locking? Is it when you're writing to a document you lock the something being trained about?
Yes. So today, you know, when a write occurs, the entire database is locked, such that only that one writer has the ability to update that one document, right? So if you're trying to do something highly concurrent with lots of readers,
So now it's down to the collection of the document.
yeah, collection or document, yeah. Yeah?
The other question, I apologize. So, you brought up a good point about, you know, what's going to be included versus not. So, again, we're open source, even though we own the IP. If you guys want to see specific functionality you're not seeing today, submit an enhancement request within our ticketing system. The more that we actually get built up in regards to specific feature requests, the more likely there's going to be enhancement roadmap. And I can bring up a couple conversations that Jay and I have had specifically about that. So, for example, because in-memory database computing, and more people that request it, and more becomes a priority, the more likely we'll accelerate it. So, it's the only thing I can add if you guys have specific information.
Okay. All right, last but not least, a lot of people don't know that there is a commercial version of MongoDB available called MongoDB Enterprise. So it gives you, you know, on-premise automation, all the monitoring and automation and backups that we talked about on-premise. Those things are available in the cloud from us if you choose to do that. But if you are in an enterprise that needs to have your data, you know, within your own walls, you don't want that data to go out to somebody else's data center, you can run MMS on-prem with MongoDB Enterprise. Our support team is outstanding. So we give you follow the sun support. We have support centers all over the world, so no matter where you are, what time it is, you pick up the phone at 3 a.m., someone will answer the phone. And you know, we give you commercial licenses, which are important to many people in the commercial realm, as well as access to consulting and training. So if you are interested in MongoDB Enterprise, Brendan is here to talk about that. All right, so if there's no other questions, thank you very much. Oh, question?
So if I'm a front-end guy, I don't know much about databases, and I want to learn how to work with database visually. What's like some of the better apps with GUIs?
Yeah, so there's a whole bunch of them. There's RoboMongo, MongoHub, MongoView. They're all open source, so you can go to GitHub. I like MongoHub on the Mac. I think it works really well, but other people like RoboMongo. So there's like 3 of them that are, you know, open source that you can get off of GitHub to visually look at your data. Yep.
I have a small question. Earlier you said if you use a hash chart, updates can be slower.
Potentially, yeah.
Why is that?
So let's say I'm ingesting a bunch of data and I'm writing that data. So that data that I'm writing right now is in RAM. It's going through my I/O subsystem. That's what I am focused on. Now let's say I want to update some data that I've previously imported. That data is not going to be recent. Let's say it's not. Right? So when that happens, MongoDB has to go out because it's not in RAM. It's data has to go out to fetch that data from disk. Because all of writes are essentially random. So right. So because they're random, my working set is all because I don't have like a set of data that's hot in RAM that I have to go fetch.
So if I wrote that out and then if I decide this, I can
if you have enough RAM, it depends on. So let's just assume that you have enough RAM. That would not be a problem. It's when you're doing, if you're doing lots of concurrent writes from a hashed random perspective, and then a whole bunch of updates at the same time, that you're going to get I/O. Your I/O subsystem is going to work really hard to fulfill those requests. Okay. Any other questions? All right, well, thank you very much.